Good afternoon. I'd personally like to thank Dell Technologies for sponsoring the vBrownBag. And today we're going to talk about BIOS, and it's going to relate to capacity performance and get into infrastructure. I'm going to take a little bit of a different approach in that we are going to basically tell a story about what we've seen over the past few years. And hopefully by the end, you'll be able to tie all this stuff together. Some of the slides are going to be a little bit challenging because there's a lot of information on there. And I really do intend for you to go back and look at those slides separately. I don't expect you to analyze them completely up front. So let's start. People ask me quite often how long I've been playing with VMware. And here's a story about that. Sometime in about 2002, 2003, late one Friday afternoon, a manager appeared in my doorway and said, "I need you to be in Houston tomorrow morning. We have a critical situation with a big customer." And I'm going, "Okay, so what is this?" And he said, "Oh, it's with VMware." And I had never seen VMware in my life. So he says, "I need you on a plane, take some of your cohorts with you and go down there and plan to spend the week." Well, I get up, Saturday morning, we do all that, fly in, and we get in there, and the guy greets us at the airport and takes us to their main complex and says, "Stay away from the windows." And, we were all kind of knew this coming in, but we were basically flying in to beat Hurricane Claudette into pounding Houston. And we were there for about a week with all the rain and all the stuff. And so that was my first immersion in VMware, dealing with VMware and backing it up. And when we kind of left, we actually did have a working solution for the customer. They were happy. So that's my story about how I actually got involved with VMware. I gave you that time to look through the disclaimers. So hopefully everybody's on that page. We're going to start out with telling the story, like I said. And the reason I'm doing this is because people tend to forget the facts, but they tend to remember the story. So hopefully by the end of this, you'll be able to go, well, that was the guy with the Houston story, or that was the guy with the BIOS kind of presentation. But at least you'll remember the bulk of the content if you don't get all the facts and figures right. So this started with a what if, and it kind of came back from a design error. And so we kind of drilled down on that and said, okay, we can make a paper out of this and actually use it as an educational and informational tool. And so when we threw these headlines out, it's like, what about $500,000 in capital? That's a lot of money, and that gets people's attention. But when we get to the end, you're going to see how we got at those numbers, and you're going to go, okay, that makes sense. Some of these things are very simple. Literally, you can do them in one reboot, and you can be a VMware hero by increasing server capacity overnight if you're paying attention. And we kind of just went through all this and then put this presentation together after the fact. So I'm going to give you a little bit of background. The why was basically, I'm going to show you this in a slide or two, is we had something called a Dcell Gen 3 environment, and it was running very high utilization, much higher than it should have been, with really only about 1,100 VMs, or it was running about half the capacity we expected it to be running at for that utilization. So of course, management comes in and goes, they needed to understand why, and it was more of they demanded to understand why they weren't getting their money's worth. So we had to dig in. So the bottom line up front is we went in, and after adjusting the BIOS settings, we increased the environment's capacity by about 32% overnight. And no, that's not a misprint. So you get into, we're going to show you some real performance numbers. We're going to show you real utilization numbers that we collected from this environment and what its impact has been and what it cascades throughout the environment. I'm also going to show you some supplemental materials that basically reinforce this. So, and yes, we did do this with one reboot. This is what a Dcell Gen 3 looked like at the time we actually built them. They were compact, off the shelf. Basically, you had an XIV storage unit dedicated to 9 4-socket high-performance servers. We basically had a terabyte of compute and 9 terabytes of RAM. And basically, we had 2,500 VMs, and people look at that number and go, well, how did you get that number? Basically, we had the very small VMs. This was a dev test research environment. So they were 2 CPUs, 4 gigs of RAM, and about 60 gigs of storage. That's how we arrived at how many we could actually fit at their current workloads into this actual cell. So what actually happened and how did we get here? Basically, the cell itself had, when I got the call from my buddy Jeff Fairbrother, there were about 1,250 virtual machines in that cell, and there were about 1,100 of them powered on. So if you just kind of do the math, that's about 122 to 1 ratio of what we expected, but it was running at 73%, which was way higher than what we had designed the cell to run at. So we knew something was wrong, right? So when we kind of looked at that, this is the workload that got pulled back. When you looked at the workload, this was an actual capture from that cell running with those default BIOS settings that we actually had turned on in there. And if you look at that, when we design these cells, we basically say you're going to run them to 85%, and that will be 100% of system utilization. So we really only had about 12% remaining capacity if you assume the 73 I showed you earlier, which was nowhere near enough to actually double the number of VMs that needed to be living in the cell to get to our 250 to 1 ratio. And by the way, this wasn't our first rodeo with the cell. We had built others, so we knew that this cell could actually perform at those levels. So what happened? The bottom line up front is when you choose BIOS performance or you choose manufacturer's BIOS, make sure you pay attention to their default settings. Even when they say we're going to put you in maximum performance mode, you sometimes have to pay attention to what that really means. And in this particular instance, maximum performance mode actually had some key items that had been either enabled or disabled against what I had actually specified in the design criteria for the cell. And this was just happened to be an oversight on a guy's part. When he was setting the cell up, he didn't go in and make those adjustments. So what actually happened was you needed to disable basically the C states. You needed to disable the P states. That includes C1E. We also had to turn the QPI frequencies up to high. A very odd one that most people ask me about is why would you disable turbo mode? Basically, for turbo mode, we're after very consistent performance because our testing engineers get very upset when they make one run and it's 10 seconds and they make another run and it's 20 seconds. So that is just a means to level out and control the amount of variance within these cells. So when we went back in and we put in the correct BIOS settings, this is what immediately happened to the cell. The workload dropped to about 41% from the 73% it was running earlier. So this was an immediate recovery of capacity and performance within the cell. So if you take those numbers, and I'm kind of shoehorning here, but basically at that workload level, we estimated we could safely double the number of VMs within the cell to about 2,200, 2,250. And that would take us from the 122 to 1 to the 250 to 1 ratio that we had actually promised and we knew we could deliver and still keep that cell running at 80, 85% utilization, which would be, quote, 100% utilized. A bonus thing to keep in the back of your head basically is to, when you do this, when you run these cells at 60, 70, 80% utilization, you're running the power supplies in the most efficient operating mode for them rather than running them at 10 or 20 or 30%. And that comes into play a little bit later, and I'll show you some of that in some future slides. So I wanted to show you a summary before and after picture. That was the before. This is the after. So you can see I tried to kind of line up the things so you could take a look at it and look down the column and go, yeah, that's a big change. All right. And it was a very easy change. And it's something that people really need to pay attention to. So this is the guts of this presentation in terms of what we're going to cover. Now we're going to basically go in and we're going to do a deep dive on some other things we see in these cells or some other things we've seen over the last few years that tie directly back into this. So this is my free public service announcement for the day. I know most people hear this, maintain your firmware, keep it up to date. And a lot of people think that's the most grudging work that there is. Well, this is a good example of why that is really necessary. And it's something that VMware and all have been working on the last few years, making this a lot less painful. This is one example of when our team went in and they updated the firmware. And that drop in CPU utilization is about a 200% improvement with an update to firmware. And people go, well, why is this important? Well, typically, I've worked for some of the largest hardware vendors in the world, and typically what happens is it's just like any other software. Firmware and BIOS are just like any other thing. And so things that get pushed out early on may not be performance oriented, whereas things that come out later in the cycle, especially with new servers, may tend to go more towards improving the performance within the system itself. So this is one concrete example that I caught during my career of proving this beyond a shadow of a doubt. So let's talk a bit about VM Ready. This is a big deal to a lot of people, and I want to show this because this is another impact you see when you change the balanced BIOS into high performance BIOS and you lock in those settings and you make the changes that I'm talking about. So I want you to look at this slide. It can be a little bit of an eye show, but the information to the left of the screen where you see the red lines, that is percent ready for a VM. If you look to the right of the orange line, that is also the percent ready for the same VM. The difference between these two readings is the one on the left is run in balanced power mode. The VM on the right is actually moved to a host that's running in high performance mode, or what we call hot mode, highly optimized performance mode. That's my little coin synonym. If you look at the gray area, you'll see that the overall VM average utilization is the same, but there's a drastic shift in the amount of ready running that has to do with the latencies within the CPUs and the latencies within the wake-up states. And this can make a huge difference in what you're seeing and reporting. And when you think you have a problem, there could be a very easy fix to this. Now, we were not the first people to actually come back and put this together. Back in 2014, Red Hat actually put up a slide in their Red Hat Summit. And I nearly fell out of my chair when I saw the slide, because if you look at this slide, you can see and recognize the exact same information I just showed you on the prior slide present in this slide. And this is exactly what's happening when you're running stuff in balanced power mode versus high performance mode, where you go into basically all the C states are turned off over to the right, whereas to the left, all the C states are turned on. So this is the same information you're actually seeing. You can see these changes ripple throughout your VMware infrastructure. So I'm giving these guys credit for putting up this slide because it is still very accurate today. Now we're going to jump in and look at some more VMs, and I'm just kind of showing you this is a completely different set of VMs running a completely different set of VMware settings. And the setting on the left is the VM running in balanced power mode. These are basically ETL VMs. They're transform and load VMs. We're a big analytics company, so we do a lot of data transfer and transformation and loads. So basically, the balanced power mode is on the left, and this is a 1 week view. The center mode is the same VM swapped to a host that is running in high performance mode. And then the third iteration over to the right is it got moved back. So I'm trying to show you this was not a fluke over a week. Now, if we take a look at just basically 1 day, you can see that the peaks and the utilization of the VM in high performance mode is much higher. So that VM is basically, in theory, doing a lot more work than the VM when it's in balanced power mode. So it's able to push a lot more transactions through, it's able to process a lot more data. And, just eyeballing this, basically, we see, about a 50% change here, or, we think that VM could be delivering up to 3 times the performance of the workload as the same VM running on a balanced power mode host. Now I want to jump into the power supplies. Remember, I mentioned those earlier. And I want to call your attention to the middle of the screen where it says last day. And this is from a Dell box. And we're looking at the yellow line here where we see the erratic power consumption. If you think about this in balanced power mode, this is exactly the same red graphs you saw earlier with VM Ready, as well as the Red Hat picture. So what's happening is basically the power supply is mimicking and showing us what's going on here. And the thing to remember from this slide that I'm going to have to call back to later is the average power mode is like 448 watts or 496 watts is the maximum that's used. Now, if you kind of take and look at the same host that has been switched into high performance mode, you see in the middle graph that the peak line has gone flat. No more crazy erratic movements. And we basically are mirroring again what we saw with the red lines in the earlier graphs. And I want to call your attention to the fact that the change in the power consumption has gone to an average of 463 watts versus 448 watts, or about 15 watts. Now, if you look at the peak power, it's gone from 496 to 499, so that's about 3 watts. So the bottom line is the net difference between these two operating modes is about 3.35% increase, but you're making substantial gains in the overall perception and performance of the VMs running on these machines when you make these BIOS changes. Basically, it's a win-win for everybody. Now, I want to jump in and put a different spin on this from a business perspective, where we start talking about labor rates and a few other things. And I want to try to marry this back into the business side of things to kind of help frame this in a financial point of view. So there's a paper written by a guy named James Hamilton in 2008 where he fully calculates the burden cost of power, and he estimated that it was $2.12 per server per year per watt that could be saved. And he basically did a calculation on his huge data center. So just for fun, I wanted to adjust this to 2021. So 212 now is $2.68 in 2021. And I want to take this number and I want to apply it in different ways to what I've been telling you is going on here, and help you see that sometimes the tail is wagging the dog instead of the dog wagging the tail. One thing I also want you to remember is Mr. Hamilton summarized that sometimes it's just as important to know when not to use something as when to use it. So just because there's a feature out there that looks cool, it may not be the best thing to always use. And I'm kind of making an analogy here to the balanced power versus the optimized. So the bottom line up front is using the balanced power default in the BIOS settings is not a very efficient IT operating or business investment model. And we're going to go into a couple of changes here and a couple of charts that are basically going to present this. But these are some of the charts that I'm saying you're going to have to go back and look at because they're a little bit of an eye challenge. So I'm going to present the balanced power on the left. And we're going back to our vCell at the very beginning, where we had, the cell running, 73% with a 32% savings. So I went and did the math and basically figured out that we would have to have added 7 additional servers to that cell to pick up the missing capacity. All right, and I want to go give you a range of, is a server $100,000, $50,000, or $25,000. So that's kind of what I'm showing you here. Plus those servers are running at about 900 watts. Now, if you turn on our highly optimized BIOS settings, basically we're doing the same work in the non-existing servers with no net new. All right, and maybe we're running the servers at 1,000 watts versus 900 watts. So that's a small change, but I'm kind of capturing this in the figures. So we have 0 capital cost on the left, and we have anywhere between $700,000 and $175,000 capital expenses on the right for buying those new servers. So if you want to run this out for 5 years and add it all up with the power, you basically are having an additional CapEx cost of anywhere between almost $900,000 and $367,000 versus the net avoidance cost that we ran when we actually just tuned the BIOS correctly. So our net avoidance, and I'm compensating for the power here, is anywhere between $772,000 and $247,000. That's a significant change, and this is where some of those numbers come at the very beginning of the presentation. Why is how to reframe this whole conversation around power and the difference it can make. Now, a manager actually asked me, well, how long could we have operated those original servers in their high BIOS mode before we recovered this money? And basically, if you just do the math out simple, I'm not allowing for time value or inflation here, we could run those original servers anywhere between 10.3 years at the low end to 32 years before we ever recover this huge amount of money we would have had to have spent to recapture that lost capacity. Now, I'm going to switch over to a actual example of a VMware issue that I ran into with a senior developer. And I'm painting this picture so that you can see there is real time being spent in these things, and it does add up. So basically, we had a developer with a desktop, and he was running regression tests, and it was taking him 120 seconds to run his regression test. They had given him, IT had given him a VM and basically a VDI setup, and it took 620 seconds to run the same set of regression tests that he was running on his desktop in 120. They gave him a second one when he complained very loudly, and the best they could do basically was 360 seconds for the same set of regression tests. So overall, if you look at what he was facing, we're talking about a difference between 120 seconds and 660 seconds, or a 450% increase in the amount of time he was spending every day for running these regression tests. And we came up with the 660 seconds because I ran a large number of iterations over different VMware environments, and we kind of came up with an average number because it varied widely. So the next slide I'm going to show you really is a series of tests. This was test 61, where we were playing with the Java, and this is where we basically got it down to running 477 seconds for running his regression test. Well, here's what happened when we changed the BIOS settings from balance mode to high performance mode with the changes I'm talking about. We immediately gained 203 seconds in advantage of the high performance mode. With that one change, nothing else changed. The only thing that changed, nothing changed in the VM. The only thing that changed was the VM got moved from one host to another, and these were all isolated hosts. There was no other workload on the host whatsoever. So basically, there was a 54% difference between those two numbers with that one change. So this is a real example of one developer seeing a difference, or the difference that could be seen with just one developer running regression tests on a virtualized environment. Now, this slide here, I'm trying to tie the labor in and bring it back together. This slide here is from a VMware presentation, I think on vSphere 5, and it's the perfect slide to show you what's going on between high power, balanced, and low power mode, and the varying workloads that are going from 0 to 60%, basically. So I'm trying to compare here on the left for you to show you that at 0% to zero power savings, obviously, right? But the one I want to focus on is the green one, which is a load of 30%, which says there's about 11% power savings between the high and the balanced mode, right? And we're just got to eyeball it because I don't have the actual data. But what's involved in there is the frequent p-state transitions. Again, you can see that green line doing the jiggle like I showed you earlier with the red lines. That green line is doing the same thing. And when you want to look at this and try to estimate the numbers, again, I'm going to focus on the green line. I'm going back to the $2.68 per year per watt. It looks like there's a difference of about 30 watts. And if you want to do the math, it's about $80 per year per server, difference between the balanced power mode and the high power mode. But the results are obviously quite different from the user's perspective. So this is when I say, is this the tail wagging the dog or the dog wagging the tail? We're going to look at a negative challenge and bring this into actually an FTE perspective, but we need to kind of summarize these slides. The bottom line is, if you look at the slides I showed you earlier, is that if you extend one FTE's task by 1 hour, then the savings that you would have gained in balanced power mode completely offsets any of those savings at $80. So here's an FTE, simple FTE burden rate. I'm going to focus on, $150,000 burden cost. If you look at that with a 2,000 hour schedule, 8 hours a day, that's about $75 an hour. All right, well, there's your $75 you're paying your developer versus the $80 you would have saved in power for the year. So it only takes 1 hour to recover your entire amount of savings that you could have proposed. So this is why I keep saying that using the manufacturer's recommended default BIOS settings is not the most efficient business investment or IT operating recovery model by far, but it happens an awful lot. So in conclusion, basically what I'm trying to tell you is the percent ready flatlines when you do it correctly, the jitter decreases, your overall throughput of the operation can increase, your time that your developers and your other people are spending running workloads, whether it's analytics or whether it's regression tests, can be quite shortened. And you really can't win that FTE time back in raw electrical power savings. You just can't win it back when you look at it from that angle. Now, the summary recommendations are kind of captured here. So what I'm talking about, basically, I'm saying set everything to maximum performance in the BIOS. I'm talking about disabling C states. Basically, we disable prefetchers because in heavy virtualized workload, they're more trouble than they're worth. We turn on QPI power management. We disable our process performance states, C states, P states. We disable MWait. I can send you a whole list of these if I can, but I try to capture most of them here. We disable cold fast boot, which is a memory test, which is something that you guys may have been reading about recently. We disable OS throttling, make sure that the Windows isn't throttling or et cetera is going on behind the scenes. And so this is this is a very high level list. And I'd like to go into the special thanks for the people who made this possible at this point. There were a lot of people involved in the presentation. And special thanks to Mr. Joseph Hatcher, Jeff Fairbrother, who was the co-author and the guy who kept asking me, why is it like this? Kim Nylander basically edited numerous early drafts, as well as my wife, Karen Mobley, who always advises. These are the references for the documentation and the documents I referenced, as well as some of the pictures and photos. These are the notices about trademarks, etc. These are some notes on how I got the calculations, and thank you.